Hi everyone, today we're going to be talking about the rigid transformations. The rigid transformations are translation, reflection, and rotation. You do these transformations on shapes or points or lines in a graph. Here's a triangle in a graph, and I'm going to perform each of the transformations on the triangle just to show you what I'm talking about, and then we'll talk about them each individually. So that was a translation, because the triangle moved across the graph. That was a reflection across the y-axis. That was a reflection across the x-axis. And that was a rotation 90 degrees clockwise around the origin. So first we'll talk about translation. Translation is when the shape or line or point is moved. Each point moves the same distance and in the same direction. In this example, each vertex moves 7 spaces to the right and 2 spaces down. You can see this by counting each of the spots that the triangle would go across the graph. So this goes 1, 2, 3, 4, 5, 6, 7 to the right and 2 down. The next transformation is reflection. When you think about reflection, it's easy to think about a mirror. If you see this picture of the mountain in the lake, you can see that the mountain is reflected across a central line. That's exactly what's going to happen in the graph and when you transform a shape or line by reflecting it across a line. This triangle is reflected across both the y-axis here and the x-axis here. When it reflects across the y-axis, it basically flips over this y-axis, and this y-axis acts as a mirror here. The same thing happens in this x-axis. The shape is kind of flipping over the x-axis, and it's like there's a mirror placed right here. Each point is the same distance from the center line as each point in the reflection. And the central lines can be in any direction. So you can pick a line like here to reflect off of, or you can pick a line here to reflect off of. Most of the time they'll be off of the axes, but they can also be reflected over any line in the graph. The next transformation is rotation. Rotation means to turn a shape or line around a center. So in this case, this shape, this triangle, is rotated around the origin. It's rotated in the counterclockwise direction, and it is rotated 90 degrees. Rotations can be described by both the direction and the degree. So the direction will either be counterclockwise or clockwise, and the degree will most likely be 90 or 180. The easiest way for me to think about this is that if the object is rotated 90 degrees, it will be rotated into one of the quadrants surrounding the quadrant that it originated in. If it is rotated 180 degrees, it will be rotated into the quadrant opposite of the quadrant it originated in. Rotation can also occur around any point in the coordinate plane. So you could also rotate around one of the vertices of the triangle or around a point down here or any point in the coordinate plane. So let's practice. Line AB is in the coordinate plane. We're going to translate the line to the left 10 units. Where is A prime? A prime is just a way to say the transformed version of the line. So when you see a letter with the prime symbol on it, that just means that it's indicating that point in the transformed version. So if this line is translated 10 units to the left, this point A will also be translated 10 units to the left. To translate this point 10 units to the left, we can also think about it as subtraction. So this point is at coordinates 1, 2. Since its x-coordinate is at 1 and then we're moving the A point to the left 10, that's like subtracting 10. So we're going to take 1 minus 10, which will give us negative 9. And then the A point does not move along the y-axis because it's only being translated to the left and not up or down. So the new coordinates of A will be negative 9, 2. Now we're going to reflect line AB over the x-axis. This is asking where A prime would be. So if A is reflected over the x-axis, this axis here, it's going to be the same distance away from the x-axis that it was originally. So since this point A is 2 units away from the x-axis, it's going to be 2 units away from the x-axis here. So A is going to be at 1 because it didn't move anywhere across the x-axis, it only moved across the y-axis. So it's going to be at 1, negative 2. Now we're going to reflect the same line over the y-axis, and we're going to look at B instead of A. So now we're transforming and reflecting the AB line over this axis. So we're going to count how many spaces B is away from the y-axis. So it is 1, 2, 3, 4, 5 spaces away from the y-axis. So it's going to be 5 spaces in the opposite direction. So it'll be 1, 2, 3, 4, 5. It'll be at negative 5 on the x-axis. And then the height of B, or its position along the y-axis, won't change because it's being reflected across the y-axis. So B prime would be at negative 5, 1, 2, 3, 4. B prime would be at negative 5, 4. When I first look at this problem, I see that this is a rotation around the origin 180 degrees. Each of the vertices are going into the quadrant opposite of the quadrant that it originated in. And I can see that if this whole graph were rotated in this direction, the triangle would end up looking like this if it was rotated 180 degrees clockwise. So that's one of the ways that this transformation could happen. There's actually another way. You can do this transformation by reflecting the triangle too. So you can start by reflecting this triangle across the x-axis. So if you look at the original triangle, you can see that this is what it would look like if it was reflected across the x-axis. And then when you rotate this triangle across the y-axis, you get the triangle that you transformed it to earlier. So there are some times where you'll have multiple ways where you can transform an object or a line to get to the same answer. There are many ways that can be correct, but it's just a matter of figuring out one of the ways. Okay, some review. Translation of a shape or line is moving the shape in a certain direction. Each of the vertices in the shape or line will be moved in the same direction and the same amount. Reflecting a shape or line occurs across a central line, most of the time across y-axis or x-axis. This is like reflecting an object in a mirror. The shape or line will flip over the axis or central line that it is reflected over and result in a mirror-like image. Rotation of a shape or line occurs around a central point and is described by both the direction of the rotation and the degree that the object or shape or line was rotated.